Hello wonderful person, this is Anton, and it's about time we've talked about some of the major updates from the mission on Mars, specifically the helicopter mission known as Ingenuity. And there have been some major updates, specifically in regards to the difficulty that the mission is facing right now. And there's really one major difficulty. It's becoming more and more challenging for the helicopter to fly on Mars. And so let's talk about some of these updates and some of these new discoveries and talk about the future of this mission as well. But let's obviously start with the question of what's so difficult about the flight and what's really happening with the helicopter. Well, obviously because of this mission, we've learned quite a lot about the Martian atmosphere, and we've also learned a lot about the ability of helicopters to fly on Mars. As a matter of fact, the future missions that are probably going to be responsible for recovering some of the samples from Mars are already being changed to potentially being helicopters as well. For example, it's really impressive that the scientists, by just knowing what the atmosphere of Mars contained from some of the previous missions, were able to work out the exact size and the exact speed with which the helicopter blades had to spin in order for the helicopter to be able to fly and to be able to function for so many months. But when the mission was being created, nobody actually expected for out the exact size and the exact speed with which the helicopter blades had to spin in order for the helicopter to be able to fly and to be able to function for so many months. But when the mission was being created, nobody actually expected for the helicopter to last so long and for the mission continue past the initial 5 flights. And because NASA has now expanded the mission, the scientists behind Ingenuity are facing a lot of new challenges. One challenge here being Mars itself, and specifically the Martian atmosphere and the Martian climatic changes. Because just like Earth, Mars also has seasons. And with every single season, the conditions on the Martian surface change quite dramatically. For example, in this recent study that you can find in the description below, the scientists investigated and actually helped us visualize how the conditions on the Martian South Pole change with the seasonal variations, specifically how the South Pole develops the ice caps. Now this is really interesting because it doesn't just develop the ice caps, it also changes the density of air and thus changes the overall pressure as well. So right here there's not enough ice and a lot of CO2 circulates around the Martian atmosphere, increasing the overall pressure. But then, when the ice starts to freeze, the density and the pressure decrease, 0.5% of the Earth's atmosphere, which is below the design limitation of 1.2%. And even though the difference is only 0.2%, it's actually enough for the helicopter to start experiencing problems when flying. And so generally for any helicopter or any sort of a drone that uses very similar technology for flight, there's a really important concept known as the thrust margin. Thrust margin refers to a kind of excess thrust that allows the helicopter to perform different maneuvers, such as pitch down or pitch up, and increase its speed. In this case, the thrust margin for Ingenuity is approximately 30%. And so this additional thrust is required for a really important concept known as the thrust margin. Thrust margin refers to a kind of excess thrust that allows the helicopter to perform different maneuvers, such as pitch down or pitch up, and increase its speed. In this case, the thrust margin for Ingenuity is approximately 30%. And so this additional thrust is required for the helicopter to perform nominally. In this case, the thrust margin for Ingenuity is approximately 30%. And so this additional thrust is required for the helicopter to perform nominally. But the thing is, in these lower pressures, the thrust margin drops down to about 8%, which technically is no longer enough to perform certain maneuvers. In this case, it's sort of similar to a normal helicopter flying really high in the air, where the thrust margin is so low that the helicopter starts stalling and sort of starts dropping from the skies. In other words, it becomes really difficult to operate a helicopter when the density is really low. But there's obviously a solution to this. You could hypothetically spin the blades even faster. And by spinning the blades faster, you would produce more lift and thus produce more thrust margin as well. And so that's what the team behind Ingenuity decided to do. They decided to investigate if this could potentially be a solution, making the blade spin approximately 10% faster at the RPM of about 2800. The previous RPM was only about 2500, and so that's exactly what the scientists have been trying to do for the past month. They wanted to test if this actually works. So following a somewhat uneventful 13th flight, before the 14th flight, the team decided to test the really high speed rotation of the blades just to see if it would create any potential problems for the helicopter itself. And one of the potential problems they sort of expected is what we sometimes refer to as resonance. Now, when it comes to resonance in engineering, I think the most famous example is the Tacoma Bridge that collapsed back in 1940. This is essentially the example of what resonance can do if a structure is built incorrectly. You might already know the story, but essentially what's happening here is that the natural vibrations of the bridge have the exactly same frequency as the vibrations produced by the wind in this particular region. And because of this, the wind ends up magnifying the vibrations of the bridge itself, which then sort of oscillates even more and eventually collapses because it just can no longer sustain itself. And so in theory, something extremely similar could happen to the helicopter if the blades spin at the resonance that's similar to the other vibrations produced by the helicopter as it flies through the air. Because it was never tested at these particular RPMs, it's unfortunately unknown to the scientists if the resonance is going to be produced until they actually test it and until they make it fly in the Martian atmosphere. The other obvious problem is the fact that it's going to need more energy. Because of the 10% higher RPM, the system will have to withstand much higher loads, and this could potentially wear out some of the parts much faster. And then there's also the problem of the speed of sound itself. At 2800 RPM, the blades are going to be spinning at about 80% the speed of sound on Mars. And because of this, they're going to start experiencing a lot of aerodynamic drag, which in turn will actually make the flight itself extremely difficult. And so at these really high rotation speeds, it becomes almost impossible to make this flight efficient. Nevertheless, before the 14th flight, the scientists decided to test this on the ground, and the test was completely successful. The blades were spinning just fine, and it seemed to have been working. And so the scientists were planning to perform the 14th flight back in mid-September.
Greedier businessmen are also looking at the possibility of mining the precious metals within the 113-kilometer asteroid, thought to be worth a staggering $10 quadrillion. Comparatively, the combination of all currency on Earth only totals to $80 trillion, give or take. A dark mission, 2022. The European Space Agency will be launching its Euclid mission in 2022 for the purpose of studying the theoretically assumed and until now undetectable dark energy and dark matter. Very little is known about a substance that scientists say must exist and contains 95% of all the matter in the universe. An orbiter will launch from Cape Canaveral, deploying a telescope with the Near Infrared and Photometer, or NISP, instrument needed to assess why billions of galaxies are moving away from us at an abnormally fast rate. It's suspected that cosmic bodies traveling faster than the rate of expansion are being propelled by dark energy, the great mystery of this century. Life within our solar system, 2023. Scientists want to launch a spacecraft in 2023 to survey and assess the fourth largest of Jupiter's 79 moons, Europa. The purpose of the mission is to sample some of the ice which covers the surface of Europa, ice made from water that scientists suspect is twice as old as the water found here on Earth. If their theories are correct, Europa may even contain more than double the amount of water underneath its icy crust than is held by all the seas and oceans on our blue planet combined. In broader terms, a question needs to be answered. Can Europa sustain biological life and one day human life? Martian Moon Mission 2024. The Japan Aerospace Exploration Agency, or JAXA for short, will be launching a mission to the Martian moons of Deimos and Phobos in 2024. The main objective is to find out if the moons are residual chunks kicked out into orbit from Mars' surface after its formation or as a result of direct meteor strikes. Then again, they could just be large asteroids that were captured in its gravitational pull as they traveled close to the planet. Both moons have a decaying orbit, meaning that one day they will both crash down into the Martian surface. It's unclear which moon will meet its doom first, Deimos or Phobos, with the race neck to neck and due to be decided in about 50 million years' time, a time when human civilization will almost certainly cease to exist. First woman on the moon, 2024. It's been over 50 years since the first manned mission to the moon. We're set to return, and as a tribute to the Apollo mission that took them there, the next decade will be all about the strong women that stand beside every strong man, his sister Archimedes. The new lunar program aims to allow mankind to once again step foot on the moon's surface, but for the first time in history, some of those feet will belong to a woman. NASA is developing a powerful new rocket to get us there. Attached to the top was the Orion-class spacecraft. The Gateway spaceship will act as a base of operations and house astronauts as they go back and forth to the moon, developing working technologies that will eventually be used in the first manned mission to Mars. Day turns to night, August 2nd, 2024. A total solar eclipse happens when the moon passes between the Earth and the Sun, effectively obscuring our bright golden ball for those standing in the shadow cast over our blue planet. Due to its close proximity, the moon's relative diameter is larger than the Sun, blocking all direct sunlight and turning day into night. The one happening in 2024 will be unique, with the moon's diameter being larger than usual, occurring a day after the perigee. The longest duration will be 4 minutes and 28.13 seconds near the town of Nazas in Durango, Mexico. It will also be the only total solar eclipse in the 21st century that will be totally visible in Mexico, the US, and Canada. Interestingly, a smaller partial solar eclipse happens just 177 days later. Comet 9P Tempel 1, May 26, 2024. Comet 9P Tempel 1 orbits the Sun within the asteroid belt located between the orbits of Mars and Jupiter. It last achieved perihelion, otherwise known as a close approach to the Sun, in 2016. It takes the comet roughly 5.5 years to orbit the Sun. In 2005, the Deep Impact mission sent an impactor into the comet, becoming the first spacecraft to eject material from the surface of a comet and then collect it for study. On May 26, 2024, it will pass relatively close to Jupiter, roughly half the distance from the Earth to the Sun. Coming within this proximity of the supergravitational gas giant may be the end of the comet, causing it to break apart in a fiery doom. A titanic effort, 2027. NASA will launch its Dragonfly drone spacecraft in 2026 to explore the largest of Saturn's 62 known moons, Titan. It's uncertain whether the moon could be classed as a microplanet, as it's an ocean world with a dense, hazy atmosphere with seas of liquid methane instead of water. Massive clouds in the sky can rain and even snow methane. Titan is the only other place in our solar system with a similar atmospheric pressure to Earth, composed almost entirely of nitrogen, just like ours. The Dragonfly will be exploring various locations on the moon to determine whether the conditions on Titan mimic the Earth billions of years ago, well before the formation of life. The Dragonfly mission will arrive at the planet in 2036 and will shed light on how the first organic chemical compounds formed on Earth acted as a precursor building blocks for the primordial soup, where life eventually sprung into existence. Message in a Bottle, 2029. A Message from Earth, or AMFE, is a super high-powered digital radio sent out from Earth on October 9, 2008, with the express purpose of being intercepted by an alien civilization. It was pointed in the direction of Gliese 581c, a planet mad famous for being the first super-Earth to exist in an orbit in the Goldilocks zone or habitable zone of a sun. This is a distance from the Earth star where liquid water can theoretically exist, and therefore a potential to contain organic life. It's only 20.37 light-years away in the constellation Libra within our own Milky Way galaxy. The AMFE signal is actually a time capsule containing 501 messages that were selected as a result of a competition on social networking site Bebo. Ukraine's state space agency lent their advanced RT-70 radar telescope to broadcast the message. Too close for comfort. October 13, 2029. The near-Earth asteroid Apophis will make an extremely close pass to Earth on April 13, 2029. Well, in proportion to space terms anyway. It will fly past at just 31,200 kilometers away from the surface of our planet, or 0.0002 astronomical units. To put it another way, that's just 2/10,000ths of the distance between the Earth and the Sun. A scary thought, as there's satellites in the Earth-bound geosynchronous orbit that are further away. Apophis was a cause for concern in 2004 after initial observations and calculations gave the asteroid an alarming 2.7% chance of crashing into the Earth. That's a 100-foot wide chunk of rock we're talking about. It was later found out that it would pass through a gravitational keyhole and will likely miss the Earth, though it's still on the Level 1 watch list. There is nothing more visible or recognizable in the vast night sky than the stars sparkling in the heavens above. But what do we know about stars, aside from them being pretty to look at? How big is our sun compared to other stars we've found so far? Welcome to Factnominal, and today we're exploring the 10 biggest star discoveries in space. What is a star? Stars are immense, luminous balls of burning hot gas called plasma. They're held together by the gravitational force exerted on the atoms that make up its huge mass. From the perspective of Earth, they look tiny, but it's only because they're so far away. In fact, our closest star, Alpha Centauri, is 4.367 light-years or 1 trillion kilometers away. This means that light, traveling at almost 300,000 kilometers per second, would still take years to get there. To put it into perspective, a space shuttle sent out from Earth would take a little over 100 years to reach the nearest star to our own sun. And they would be there for 4.367 years before the Earth receives broadcast announcing their arrival. The energy produced by a star is emitted as light, heat, energy, and radiation as a byproduct of the nuclear fusion happening at its core. 4 hydrogen atoms are squeezed together so tightly by the incredible gravity and weight of mass that they're transformed into the 2 protons and 2 neutrons that form a helium nucleus. Stars literally exist because of the balance between 2 opposing forces: the gravity formed by their mass trying to make the star shrink versus the heat and energy released by the internal reaction trying to make it grow. How are stars formed? Clouds of gas and dust in space materialized after the Big Bang 13 billion years ago, as matter began to be drawn together by gravity. These clouds are the birthplace of the stars. As the gas and particulate matter begin to get closer together, parts of the cloud shrink in size and begin to collapse, forming focal points called cores within the cloud. The gravity in the cores increases to the point where it gets so dense that nuclear fusion begins, and with the byproduct given off as heat working against its own gravity, a star is born. This process is known as stellar ignition, and the initial burst of light made by a newly formed star blows away much of the surrounding cloud particles, but not all. The remainder of the material left behind forms planets over time. How they're classified. The most logical way to sort stars is to group them based on their mass and temperature. Generally, the more mass a star has, the more intense the nuclear fusion reaction inside, hence the more heat it pumps out. The scale progresses from O through B, A, F, G, K, and M, where O-class stars exceed 30,000 degrees Celsius, and those in the M group with 3,000 degrees Celsius or less. The temperature of a star causes it to burn at a different color, similar to superheating a piece of metal. Stars range from red, orange, yellow to white, and all the way up to blue. Our own sun is a Class G yellow dwarf and sits in the range of 6,000 to 7,000 degrees Celsius. Stars are extremely variable in size. A neutron star is just 20 to 40 kilometers in diameter, where a white dwarf is roughly the size of the Earth. The largest supergiants can be more than 2 million kilometers in diameter, which is more than 1,500 times the size of our sun. How long do they live? The lifespan of a star is directly proportionate to the nuclear fusion reaction at its core. Supergiant blue stars burn through their fuel very quickly and can last just a few 100,000 years. In addition to the hydrogen to helium nuclear fusion, they produce heavy metals. Eventually, they give way and form a red supergiant, the biggest class of star in the universe. This red supergiant expands until it reaches a tipping point, causing a violent stellar explosion called a supernova, and for a brief moment emits so much light it outshines the rest of the universe. The end result can go one of two ways: the formation of a particulate-ejecting superdense neutron star, or the hungry infinite gravity of a black hole. As average-sized yellow stars approach the end of their life cycle, they increase in size by up to 1,000 times, their dwindling fuel supply turning them into red giants. When there is no energy left, the star begins to lose layers and forms a complex structure called a planetary nebula. The end result is the formation of a white dwarf and extremely dense star. On the other hand, smaller red stars burn at a much slower rate and can exist for billions of years. As they die out, they form a rather uninteresting brown dwarf star. How are they measured? Measuring a star is tricky business. It's a moving goalpost, as stars have no definitive surface edge to use as a marker for the origin and termination of the measurement axis. There's no cosmic ruler that astronomers can use, so instead a star is measured by its angular size, which is a width measured in degrees. The hard part is that stars expand and contract as a result of the ebbs and flows of the nuclear fusion reaction, and as a result their brightness changes, which gives stars their notorious twinkle. At the end of the day, all you can do is average out a star's size, or calculate it based on best guesses. The term used to measure a star is a solar radius, based off the radial distance of our own yellow sun. So, let's venture through the top 10 biggest stars we've discovered so far. Number 10. KW Sagittarii, 1,460 solar radii. Sitting 7,800 light-years from Earth is KW Sagittarii, a star 1,460 times the size of our Sun. If it were the central star in our solar system, its borders would exceed the orbit of the planet Mars. Despite being much larger, it burns at a little over half the temperature of the Sun. Number 9. KY Cygni, 1,420 to 2,850 solar radii. The constellation Cygnus is 5,000 light-years from Earth, and KY Cygni is the biggest star in the cluster. Unfortunately, our field of view is blocked, so we can't visibly see it, and instead we have to calculate its size based on the electromagnetic radiation and radio waves it emits. Number 8. RW Cepheid, 1,600 solar radii. We can see the constellation Cepheus from the northern hemisphere of the Earth. It contains some whopper stars, and RW Cepheid isn't even the biggest of the bunch. It's still an impressive 1,600 solar radii, and if put in our solar system, its outer margins would extend far beyond Jupiter. Number 7. V354 Cepheid, 1,520 solar radii. At 9,000 light-years away, we have V354 Cepheid coming from a group of jumbo-sized superheated stars in the Cepheus constellation. It's the one exception to the rule, as it has become cool due to its age, meaning it could be well on its way to an explosive supernova status. Number 6. WHO G64, 1,540 solar radii. This poor WHO G64 star has had a hard life. It's actually located in a dwarf galaxy called the Large Magellanic Cloud that orbits the Milky Way. It's nearing its supernova death and has grown to a huge size, expelling enough mass and material to form between 3 and 9 of our solar systems. Number 5. V838 Monocerotis, 380 to 1,970 solar radii. V838 Monocerotis is an extremely unstable star. It pulses, expanding and contracting wildly as the reaction at its core burns out of control. As a result, its size changes each time it's measured by the Hubble Space Telescope. Number 4. Mu Cephei, 1,650 solar radii. With a luminance 38,000 times greater than that of our own Sun. It's part of a huge group of stars in the Cepheus constellation. Number 3. VV Cephei A, 1,675 solar radii. VV Cephei A is a part of an eclipsing binary star system and is quite unique. Its companion blue star is slightly smaller, but will one day eventually swell to become a red supergiant just like its counterpart. Number 2. VY Canis Majoris, 1,800 to 2,100 solar radii. The massive VY Canis Majoris was the largest known star for a very long time. If put in the center of our solar system, it would take up enough room to nearly reach Saturn. The constellation Canis Majoris contains an inexplicably large number of variable-sized twinkling stars. And finally, number 1, Stephenson 218, 2,150 solar radii. This is the biggest star we know of, Stephenson 218. It is so large that it has a volume 10 billion times bigger than our Sun. Placed in our solar system, it would engulf Saturn and almost reach Uranus.
I am excited to go to Mars this morning.
Our collective perseverance is what has gotten us to this day.
People love space, whether it's looking up at the stars on a cloud-free night or debating the existence of aliens. There's no doubt about it, space and space travel has captivated us since we first saw stars. But the adventure of space doesn't just lie in history, they're also in our future. Today, we're counting down 10 insane space discoveries to look forward to in 2021, and the top spot will blow your mind harder than a rocket ship. All of these were taken from the official NASA calendar, but they come from all around the world. Number 10. Let's start with a little hope. The United Arab Emirates mission goes into Mars orbit scheduled for February, but specific dates not yet confirmed. Emirates Mars mission, otherwise known as HOPE, is a Mars orbiter mission. It was originally launched from the Taganashima Space Center in Japan at 21:58 Universal Time on the 19th of July 2020, but its mission is far from over. HOPE will orbit Mars and study the various dynamics of the Martian atmosphere. It will also look at how the atmosphere interacts with outer space and the solar wind. The primary scientific objectives are to search for weather connection. These are the ones between the current Martian weather and the ancient climate of Mars, which might give us a look into its history. The study will look at the lost planetary mechanisms of Mars' atmosphere, which has recently been found to have once held water. It will do this by tracking the escape of hydrogen and oxygen, along with behaviors of the weather. There are 2 years of science operation planned, which are estimated to move into motion around the beginning of May 2021, but there's no official date yet. Number 9. Kicking off the year. The NASA Lunar Halo Orbiter, precursor for Lunar Gateway, scheduled for January, exact date not confirmed. The Cislunar Autonomous Positioning System Technology Operations and Navigation Equipment, otherwise known as Capstone, is a 12U CubeSat that does not need to be manned by an onboard presence. It's been specifically designed to go into one of the several halo orbits around Earth and to closely match the Moon's orbit. The primary objective of doing this are to demonstrate the ability of spacecraft to spacecraft navigation in this orbit. It also endeavors to verify the feasibility of this orbit so to gain experience for future flights. These will be able to use similar orbits. It's also a precursor to the possible Gateway lunar orbiting outpost that's been discussed. Capstone will travel for just 3 months under its own propulsion, but its findings will be immensely useful. Number 8. The Trojan isn't a horse. the launch of NASA flyby mission to multiple Trojan asteroids scheduled for October 16th. The Lucy mission is designed to make flyby observations of a total of 7 asteroids. It will be looking at one main belt asteroid and further 6 asteroids. They are all orbiting ahead of or behind Jupiter and are known as Trojan asteroids, a clever callback to real-life legends. Lucy is scheduled to launch on October 16, 2021. Number 7. Finding ice might mean finding life. The launch of NASA CubeSat mission to find lunar water ice. The Lunar Flashlight is a modified 6U CubeSat mission and not the only CubeSat on our list. It's designed to go into polar orbit around the Moon. From there, its main objective will be to search for water in the shadowed polar regions where there's a reasonable belief that it might be. Scientists want to find locations on the lunar surface where water in the form of ice is present at concentrations that might suggest supporting life. The spacecraft will make observations from an elliptical near rectilinear polar orbit. These will be between altitudes of 12.6 and 52.4 kilometers. The mission is going to be 2 months long. Number 6. Scouting for trouble. The launch of a NASA CubeSat mission to fly by a near-Earth asteroid at some point towards the end of the year. The Near-Earth Asteroid Scout, otherwise known as NEA Scout, is one that sounds much more critical than its launch date might suggest. The mission will be using a 6U CubeSat and will involve a solar sail to fly by and then return images of a near-Earth asteroid 1991 VG. The primary objectives of this mission is to make a minimum of one slow, close flyby so it can return the images. Scientists can then observe the asteroid's position in space, shape, rotational properties, spectral class, local dust and debris field, regional morphology, and regolith properties. The spacecraft is scheduled to be a ride-on mission on the Artemis 1, which will launch towards the end of 2021. Number 5. Red Planet Roving. NASA rover and rotorcraft land on Jezero crater on Mars, scheduled for February 18th. The Mars mission involves landing a large roving vehicle called Perseverance on the surface of Mars. From there, it's going to conduct mobile studies which will focus on the surface environment. It's going to concentrate on habitability, past life, and sample collection for future missions. The spacecraft itself has 3 major components. There are the entry systems, the descent and landing system, and the rover itself. The primary science objectives of Mars are to identify past environments to see if they were capable of supporting microbial life, seeking signs of possible living things. 4. NASA announcements. Not as technical, but still exciting. More than 12,000 people applied to be an astronaut between March 2nd and March 31st of 2020, and those applications are now in discussion. Next year, we'll get to see who's in the next generation of space adventure. Number 3. Probing Venus. The Parker Solar Probe is designed to orbit the Sun, which involves some seriously high-end technologies. It's going to be making several close approaches so that it can attempt to trace the flow of energy and study the heating of the solar corona. Nothing to do with the virus. It's also going to explore the acceleration of solar winds. The Parker Solar Probe was already launched on the 12th of August 2018 and has done 4 flybys of Venus already as it withstands the heat and sends back data. According to NASA's site, its main objectives are listed as to trace the flow of energy that heats and accelerates the solar corona, to determine the structure and dynamics of the plasma and magnetic fields at the source of the solar wind, and to explore mechanisms that accelerate and transport energetic particles. Number 2. Reaching Mars. The Chinese orbiter, lander, and rover mission will reach Mars sometime in February. The Chinese orbiter mission will make a 7-month trip to Mars. It will be arriving and going into polar orbit on February 2021, but no specific day is set. The orbiter will use high-resolution cameras to reach for the best landing site for the lander and its accompanying rover. They will separate from the orbiter and each other and make a landing somewhere in the Utopia Planitia region. Number 1. There's nothing cooler than blowing things up. The Double Asteroid Redirection Test, or DART mission, scheduled for July 22nd. As we said, there's nothing cooler than blowing things up, so this one takes the top spot. The Double Asteroid Redirection Test, otherwise known as the DART mission, is designed to evaluate the kinetic impact technique. This will be valuable in planetary protection. It will be done by striking an asteroid with a spacecraft at high velocity, which is relative to its size, and then observing the resulting change in orbit. NASA says that its primary objective is to assess kinetic impact as a method. This will be used for redirection of any future asteroids which are found to be on a trajectory to impact Earth and which might be dangerous. The test involves flying the DART spacecraft into the smaller of two asteroids, both of which are co-orbiting the Earth in a binary pair. They will be using Earth-based observations both before and after the impact to study the effects on the orbit. If you like this video, please don't forget to leave us a like to support the channel so that we can continue to bring you more great content. Your support means the world to us. We see every subscriber as part of our crew. So be sure to like, comment, and ring the notification bell if you want to fly forward to spectacular, space-tacular content and more. Space is full of weird and wonderful things, and not all of them involving little green men from Mars. Sometimes the most bizarre things astronauts find in space have perfectly logical explanations, but that doesn't make them any less fascinating. Want to take a look at the weird and wonderful world of space discovery? Welcome to Factnominal, and today we're on a mission for treasure in 10 bizarre things astronauts found in space. Number 10. The Orange Space Station. The first Italian to venture into space was an Air Force pilot named Samantha Cristoforetti, and somewhat stereotypically was also the first astronaut to successfully brew an espresso coffee in zero gravity. While on board the Soyuz TMA-15M shuttle en route to the International Space Station, she reported something strange. The ISS is mostly white with dull silvery gray accents. Imagine her surprise then when it blazed a bright burnished orange as she made her approach. She wrote on her blog, the enormous solar panels were inundated with a blaze of orange light, vivid, warm, almost alien. Though this is a rare phenomenon, it's not unheard of. When the sun hits the 16 long, thin panels that extend out from the ISS like fingers at just the right angle, it produces a halo of orange light. 9. Late bloomer. It turns out that spending time in space, and in particular living in zero gravity, has some surprising side effects. One unusual fact is that on average, astronauts that spend 6 months in orbit report a 3% increase in height after completing their return to Earth physical examination. This increase is caused by the vertebral bodies increasing distance away from each other as the cartilaginous discs are not becoming compressed by a downward acting gravitational force. It's the same concept as humans generally being taller in the morning than in the evening. In January 2018, Japanese astronaut Norishige Kanai tweeted that he had gained a whopping 3.5 inches during his time aboard the ISS, breaking all records. That's a gain of over 5% and almost double that normally seen. Number 8. Alien bugs. Russian cosmonaut Anton Skarpalov made an extraordinary claim. It was so controversial that NASA remained tight-lipped and refused to make an official comment. Skarpalov told Russian news agency TASS in an interview that bacteria he discovered on the outside surface of the ISS was of extraterrestrial origin, and there is only one explanation. They settled on the surface after coming into contact with the ISS in space. He quickly went on to explain that the bacteria pose no danger and are common on Earth, but how they got there and the fact that they could live in the void of space is one that's yet to be explained. Number 7. To twin or not to twin. There are two American brothers that share not only a special bond, but genetic material as well. Mark and Scott Kelly are identical twins. They are both captains in the U.S. Navy and both spent time on the International Space Station. NASA decided to perform a curious experiment, analyzing DNA samples from the twin brothers while one was in space and the other had his feet planted firmly on the Earth. What they found was that over a 340-day period in 2016, Scott's DNA changed by a surprising 7%. Technically, the two are no longer considered identical twins. DNA is made up of 98.5% junk DNA, which has nothing to do with our gene expression. The changes didn't affect physical characteristics, with NASA continuing their research into the how and why. 6. Was it space junk? Christopher Cassidy is a U.S. Navy SEAL, a man proven to remain calm under extreme stress. He was the 500th astronaut in space and has completed several missions to the International Space Station to perform critical repairs over hours spent working in the void of space. After coming back from one of these spacewalks, Cassidy made a report to Mission Control that he saw an unidentified flying object make its way past the ISS as he looked out of the viewing port. NASA was quick to clarify that it was most likely an antenna cover, as they received word from Russian flight control that the Zvezda service module had shed part of its external shielding. Still, Cassidy remains convinced that what he saw was entirely different to the space junk NASA claims was in the area at the time. Number 5. Another crazy side effect of an extended stay in zero-G is that you arrive back on Earth looking substantially younger than when you left. And no, it's not some cosmic time warp, it's just physics and human physiology at work. Weightlessness causes body fluids to move toward the head and pool there. On Earth, gravity assists circulation in draining these fluids, but of course, there's no gravity in space. The upside is that facial skin looks fuller, wrinkles are filled in, and any sagging skin retracts back into something better resembling how it did during youth. The downsides are that this blood and spinal fluid that pools in the head causes astronauts to experience unbearable migraines. But funny enough, the remedy is a simple one: relieving your bladder. Number 4. Whistle while you work. The final reconnaissance mission to the moon was Apollo 10, before Apollo 9 took Armstrong and company to be the first men to walk on the moon. It was this reconnaissance mission that was responsible to orbiting and testing the launch of the lunar module. A bizarre phenomenon was reported by the crew of Apollo 10 in what was described as space music. As their spacecraft orbited around into the shadow of the dark side of the moon, an area, by the way, that's out of radio contact due to the eclipsing area of the moon, the trio heard a haunting melody in their helmet audio. It sounded exactly like someone whistling, with a note and chord progression indicating it was not mere interference. It's been heard on other missions, and to this day, there is no rational explanation for what causes it. 3. If you don't use it, you lose it. To top off the list of weird things to happen to astronauts in space, these brave souls experience shrinking legs. The muscles in the hips, thighs, and calves wither away and atrophy, a process that begins almost immediately when not in the presence of gravity. On Earth, leg muscles are tasked with carrying around our immense bulk as we walk, run, and move around, working against gravity to hold us upright. In space, astronauts float and don't use their legs much. Even the bones decrease in density and become thin and weak. It's a major reason why time spent in space is usually limited to 6 months at a time. Even though they employ a brutal exercise regime while in orbit, astronauts still experience immense pain upon returning to Earth as their muscles get used to working again and bones gradually build up tolerance to the resistance. Number 2. Cosmic fireflies. John Glenn is one of the most well-known astronauts, and he was the first U.S. citizen to orbit the Earth. During his landmark 5-hour flight in 1962 aboard the Friendship 7, he orbited the Earth 3 times before splashing down safely in the Atlantic. During this mission, however, he reported seeing a peculiar sight out of the viewing port of his ship. He described tiny stars, unidentified speckles of light floating around the outside of the craft. NASA Mission Control were worried that Glenn was hallucinating and that he was experiencing a hypoxic episode or even a minor stroke. Worse yet, that something was wrong with the spaceship. Later that year, the phenomenon was reported again, and further investigation uncovered the space fireflies as harmless droplets of condensation on the outside of the spacecraft. Finally, number 1, space soda. James McDivitt and Ed White flew aboard the Gemini 4 mission, where they made history by orbiting the Earth 66 times over the span of 4 days in 1965. In 1999, McDivitt recounted a chilling experience as part of the NASA Oral History Project. He recalled that he saw something outside the spacecraft. It had a geometrical shape similar to a beer or soda pop can, with a long, thin object like a pencil poking out the top. NASA has offered several explanations, maybe a discarded retro rocket or the sun's reflection in the glass. He maintains that he photographed the UFO, however the mission images NASA provided for his review were not the ones he took. Most planets outside of our solar system are boring and unremarkable. If they had a favorite color, it'd probably be beige. Whether made from desolate rock or giant balls of gas, they're rarely interesting, save for a select few. So what are some of the strangest planets we've discovered so far? Welcome to Factnominal, and in today's video, we're dusting off our galactic passports and checking out 10 of the strangest planet discoveries. Number 10. Tres 2b, population bloodsuckers. This place may very well be a vampire's paradise. It's covered in a blanket of perpetual night. It's 1.5 times the size of Jupiter, with a surface that absorbs light better than charcoal and is blisteringly hot. If hell was an actual place, this would be it. Even on the ex-planet, now dwarf planet, Pluto, we would have enough light to be able to see around us on its daytime surface. But this planet is the darkest celestial body we've come across in centuries of surveying the cosmos, reflecting just 1% of the light that hits the surface, absorbing the rest. A sinister dark red glow is emanated from a smoldering atmosphere with air temperatures as hot as molten lava. It gives the dark planet an ominous glow and a look of pure evil and insanity. 9. Gliese 436b, best of both worlds. When you picture an ice cube, the image of a cold beverage with condensation on the glass comes to mind. The last thing you would think of is ice that's over 5 times hotter than boiling water. Well, on Gliese 436b, the rules of thermodynamics still apply, but in a super weird way. It has a molten core made of a liquid rock and metal, much like Earth, covered by a thick layer of water wrapped up in a nice bow made of hydrogen. Seems normal so far, until you learn that the ice burns at close to 1,000 degrees Fahrenheit. Solid water forms on Earth as the temperature drops, but here extreme pressure transforms water into ice the same way carbon is made into diamonds. It's the equivalent of burning your feet walking across a bed of ice cubes instead of hot coals. Number 8. WASP-12b, Parasitic Victim. WASP-12b is a doomed planet, no doubt about it. Think of it like a hotter version of Jupiter, only drawn in so close by its star's gravity that a solar year of orbit takes just 1.1 Earth days. But the super short year isn't the reason that this planet has a destined date with a gloomy fate. The star's scorching heat and powerful ionizing radiation are slowly breaking it apart. Then, to make things worse, the incredible gravity is pulling the contents of the planet into the nuclear fusion reaction at the star's core. This slow death makes WASP-12b look like an egg, as broken down gas is sucked up to a point just like a huge cosmic cone. The poor gas giant is helpless and cannot escape its cannibalistic buddy, being slowly sucked dry over the next 10 million years. Number 7. OGLE 2005 BLG 390LB, Cold-Hearted. Does the surface of a planet get colder the longer its name is? In this case, the answer is yes, as low as -370 degrees Fahrenheit. Its star is a tiny red dwarf whose light and heat barely touch the surface of the planet, leaving it only a smidgen warmer than absolute zero. The ice here never thaws, stuck in an eternal winter as a barren rock incapable of sustaining life. It's hard to imagine that only a decade ago this was the most Earth-like planet, even though it sits well outside the habitable Goldilocks orbital range. Number 6. HD 189733b. Forecast: chance of rain. By all appearances, this lonely exoplanet looks like a utopia. There are no other planets in this single-star, single-planet system, and this one looks the part. It appears like a glowing azure orb, with swirling clouds pushing their way through its atmosphere. A betting man would stake size based on the liquid water. A betting man would stake his whole house on the wager that the surface has liquid water, and it would be a great candidate for a second Earth. The same man would be sleeping on a piece of cardboard under a bridge tonight. Closer inspection tells a wildly different story. The atmosphere is actually made up of hard silicate particles. In other words, it rains tiny shards of glass. And it gets better. Winds on this little blue sphere reach speeds of up to 5,400 miles per hour, or over 20 times that on Earth, ripping you apart into a fine red mist. Number 5. Dimidium. Doesn't do things by halves. The name Dimidium comes from the Latin word for half, as the planet's mass is roughly half that of Jupiter. It was the first exoplanet discovered that orbits a main sequence star. Traces of water have been found on its surface, but that's where the similarities to Earth start and end. It's tidally locked to its star, meaning the same side gets bombarded with all the solar radiation and never gets the reprieve of night. The hot side temperatures can soar, with 1,800 degree Fahrenheit winds blowing over it at 600 miles per hour. Over on the cold side, vaporized iron forms clouds that rain down ferrous metal. In other words, it hails metal. Number 4. Osiris. Comment me, bro. Named after the Egyptian god of the underworld, Osiris is a gas planet that loves first place. It was the first to be discovered via the transit method, the first planet detected in more than one manner, the first discovered with an atmosphere, the first to have its atmosphere studied in detail, the first to contain both hydrogen and oxygen, and way too many others to list. What a mouthful. Surprisingly, its atmosphere comprises of oxygen, despite being 8 times closer to the Sun than the closest planet to our Sun, Mercury. A solar year lasts just 3.3 Earth days as this ball of oxidizing, burning hot gas is bombarded by solar activity. The cosmic wind is so fierce that parts of the atmospheric gas are ripped off at 15,550 miles per hour. Carbon and oxygen follow the planet around its short orbit like a tail on a comet, hanging on for dear life courtesy of the planet's gravitational force. Number 3. Korot XO3b. Time to go on a diet. Imagine a planet the same size as Jupiter, but 20 times as dense. The gravity in such a place is 50 times stronger than that here on Earth. To give you a mental picture, stepping foot on this planet would turn you into an instant pancake, courtesy of the absolutely insane force pulling you down towards the planet's core. It's a cheeky entry, as scientists aren't exactly sure whether to classify this as an exoplanet or a failed star. It's a mystery how either a star or a planet could form so densely while being so close to a huge superdense star sitting at the center of its system. Number 2. 55 Cancri e. Two-faced. Mercury is the closest planet to our Sun. It's a hot little ball of rock, but nothing compared to 55 Cancri e. The planet has zero rotation around its x-axis, but instead spins sideways. It's in such close proximity to its star that it gets no day, no night, and technically shouldn't be able to exist. The backside is shaded, dark, and has not seen a ray of light for millions of years. The front half, on the other hand, is the complete opposite. It spent eons absorbing the intense light, brutal ultraviolet rays, and ionizing gamma and X-rays spewed out by its solar neighbor. The net result is one half of the planet is a sea of molten rock and rivers of lava, while the other is a cold desert. Number 1. Kepler 7b. Getting hot in here. Blue stars burn hot, and when they're at the end of their lives, they explode and expand rapidly outwards, forming a red giant. During this transformation, nearby objects are destroyed in the blast. Not the case for Kepler 70b. The red giant consumed the planet, but somehow it still remains intact. What's left is arguably the hottest planet we've discovered so far. A cranking hot ball of inert rock that's held together with cosmic duct tape and sheer force of will. The surface temperature is hotter than our Sun. That's over 12,000 degrees Fahrenheit. Though it survived this long in the belly of the beast, it's slowly being dissolved in the digestive juices of the dying star and will likely be eroded away to nothing well before the inevitable supernova blows it to kingdom come. Space is extremely intriguing, and some theories of the things that happen there make us wonder more about it every day. Number 10. What was there before the Big Bang? We all know that things came to be after the Big Bang, but what was there before the Big Bang? It's believed that there was an initial singularity before anything else. This is a gravitational singularity predicted by general relativity to have existed before the Big Bang and thought to have contained all the energy and space-time of the universe. The initial singularity possessed seemingly infinite density, thought to have contained all of the mass and space-time of the universe before quantum fluctuations caused it to rapidly expand in the Big Bang and subsequent inflation, creating the present-day universe. Number 9. What happens when you fall into a black hole? With black holes being one of the most intriguing astronomical objects in the universe, it's no surprise that some people have wondered countless times what would happen if you fell into one. To fully appreciate what's a black hole, we need to first understand the properties of one. A black hole is a place where gravity is so strong that nothing else can escape. Black holes are named as such because they can't reflect nor emit light, and they're only visible when they're feeding on other stars or gas clouds that come too close to their event horizons, their main boundary. Beyond the event horizon lies a truly minuscule point called a singularity, where gravity is so intense that it infinitely curves space-time itself. This is where the laws of physics as we know them break down, meaning all theories of what lies beyond are just speculation. If you were free-floating in space near a stellar mass black hole that wasn't feeding on anything, your only hint that it exists might be the gravitational magnification or lensing effect it would have on background stars. But as you flew closer to this strange spot, you'd be stretched in some directions and squished in others, a process that scientists call spaghettification. This is because the black hole's gravity compresses your body horizontally while pulling it like taffy in the vertical direction. If you jumped into the black hole feet first, the gravitational force on your toes would be much stronger than that pulling on your head. Meanwhile, if you were to plunge into a supermassive black hole, things would be considerably less scary. While it might still result in a horrible death, you might make it all the way through the event horizon and manage to start falling inside the singularity while you're still alive. You'll die either way, but at least things here will be a little less painful. Number 8. The Earth will become like Venus. Both Earth and Venus are very similar planets. They have very similar size, mass, and composition, though their main difference is that Earth sustains life, and Venus is essentially a galactic wasteland because it's mostly composed of carbon dioxide. However, climate change isn't the only thing that might affect Earth becoming like Venus. As the Sun becomes 10% hotter around 1 billion years from now, the surface temperature of Earth will reach 47 degrees Celsius, prompting the temperature of Earth to increase rapidly and its oceans to boil away until it becomes a greenhouse planet. A greenhouse planet like Venus isn't exactly the nicest place to live in the universe. Venus's atmosphere is almost entirely carbon dioxide and chokingly thick, with an atmospheric pressure at the surface 90 times that of Earth. That's the equivalent pressure of a mile beneath our ocean waves. It's so thick that you almost have to swim through it just to move around. And on top of this are clouds that are literally made of sulfuric acid. Number 7. White holes. We all know about the existence of black holes, but did you know that their distant cousins, the white hole, also exist? And if you think black holes are weird, white holes will literally blow you away. Instead of absorbing matter, white holes spew it out. To a spaceship crew watching from afar, a white hole looks exactly like a black hole. It has mass, it might spin. A ring of dust and gas could gather around the event horizon. But instead of absorbing things, they're belching matter out. Physicists describe a white hole as a black hole's time reversal. A video of a black hole played backwards, much as a bouncing ball is the time reversal of a falling ball. While a black hole's event horizon is a sphere of no return, a white hole's event horizon is a boundary of no admission, space-time's most exclusive club. Number 6. Big Rip. All good things must come to an end, and it seems like the universe is one of these. This is something established by the Big Rip, in which scientists have theorized that the universe could end up expanding so much that it will eventually rip itself to pieces. Solar systems, planets, asteroid belts, and even whole galaxies will be torn apart. Of course, that's something that will happen several million years from now, so it's not like we're going to be here when it does. But when it does, you can bet that things will not be pretty for humans. Number 5. The Drake equation. The Drake equation is a formula that's been used to estimate the number of active extraterrestrial civilizations in the Milky Way galaxy. How many alien societies exist and are detectable? This famous formula gives us an idea. The Drake equation, which was the agenda for a meeting of experts held in West Virginia in 1961, estimates N, the number of transmitting societies in the Milky Way galaxy. The terms are defined as follows. N, the number of civilizations in the Milky Way galaxy whose electromagnetic emissions are detectable. R, the rate of formation of stars suitable for the development of intelligent life, number per year. F sub p, the fraction of those stars with planetary systems. N sub e, the number of planets per solar system with an environment suitable for life. F sub l, the fraction of suitable planets on which life actually appears. F sub I, the fraction of life-bearing planets on which intelligent life emerges. F sub c, the fraction of civilizations that develop a technology that produces detectable signs of their existence. And L, the average length of time such civilizations produce such signs in years. Number 4. Time is running out. Some scientists theorize that distant celestial bodies only seem the way they look because we're actually looking back in time to see them. That means that celestial bodies were moving faster in the past than they are now because time is slowing down. Even if we don't know how much it's slowing down, we know that it might slow down to a stop if things are left as they are. Number 3. Hitler's opening speech. Did you know that the first signal broadcast strong enough to pierce through Earth's atmosphere was Hitler's opening speech at the 1936 Olympics in Berlin? That means that should aliens find Earth, that's probably one of the first things they'll mention to us when we communicate with them. It's probably the first sound they heard from humans. Number 2. The Fermi Paradox. The Fermi Paradox, named after Enrico Fermi, establishes that there's a contradiction between the lack of evidence for extraterrestrial civilization and various high estimates for their probability, such as the Drake equation that we just saw. Alien life has to simply exist in one form or another, but if that's the case, then where are the aliens? The Fermi Paradox establishes that it's much harder for life to exist than we originally thought, or that more life has actually existed and been destroyed over time. And number 1, the universe is a computer simulation. If you've watched The Matrix, then put your tinfoil hats on because the universe might just be like the movie depicts it. The simulation hypothesis, or simulation theory, is the proposal that all of reality, including the Earth and the rest of the universe, could in fact be an artificial simulation, such as a computer simulation. Moderator Neil deGrasse Tyson, director of the museum's Hayden Planetarium, put the odds at 50-50 that our entire existence is a program on someone else's hard drive. He noted the gap between human and chimpanzee intelligence, despite the fact that we share more than 98% of our DNA. Somewhere out there could be a being whose intelligence is that much greater than our own. The main argument for this theory is based on the universe's laws. As the more scientists learn about the universe, the more they realize that it's very similar to a computer simulation. If you enjoyed this video, don't forget to subscribe and leave us a like.
The training process for me is incredible because no day is the same.
We've been learning to fly T-38s. We've been learning to fly the robotic arm. We've been learning space station systems.
You're constantly changing your focus, but you always have that one part of training that just your brain isn't wired for. And for me, that's learning Russian.
For anyone aspiring to become an astronaut, stop and think for a moment. Space is scary. It's pretty much the last place you want to be. It's cold, empty, dark, and full of unexplained mysteries that are the stuff of nightmares. So what are some of these creepy facts that you can't unlearn after hearing them? Number 25, cosmic beautician. People pay good money to get rid of dead skin on the bottom of their feet, but space has you covered. While in orbit, dead skin peels off in huge chunks, as you no longer need it to protect your feet while walking. 24, monkey feet. After the skin peels off, astronauts form rough, bulbous calluses on the top of their feet from using them to hook around bars and grip while floating, much the same way that a monkey uses its tail. 23. Don't forget to recycle. Water's scarce on the International Space Station. It's not just like you can turn on the tap. For someone to live up in space for a full year, they have to drink 730 liters of their own recycled body fluids. That's right, sweat and pee. Number 22, unforeseen forces. There's something we can't see, detect, or measure that's pulling galaxies apart and driving them towards a single point at tremendous speed. It's not a black hole, but the mysterious dark force, a rather unimaginative name for something we know nothing about. 21. Eternal darkness. Eventually, our Milky Way galaxy will merge with other surrounding galaxies, forming one super big galaxy. If it sounds like a bright, shining place, it won't be. The quickening expansion of the universe will pull galaxies apart faster than light can travel, creating a dark void despite the bright light of all those stars. Number 20. Deep impact. Small meteorites pepper the Earth all the time, with some bigger than others. The 1908 Tunguska event was one such meteor that thankfully broke apart in the atmosphere 3 miles above Earth. Despite that, it flattened 80 million trees in an area of 830 square miles and broke windows hundreds of miles away with a shockwave 1,000 times stronger than the Hiroshima nuclear bomb. 19. Another deep impact. Russia seems to be unlucky, as another meteorite broke up in the Earth's atmosphere in 2013. 400 people living in the region of Chelyabinsk were injured by the falling fragments. It's scary to think a meteor could fall to Earth at literally any time. Number 18. The Mayans knew. The world didn't end in 2012, but the Earth missed out on being bombarded by a solar storm of unprecedented proportions by just 2 days. If it hit the Earth, every piece of technology would have been rendered useless, putting us back into the Stone Age. 17. Who cut the cheese? Though you can't smell space directly, astronauts have reported a funky odor on the outside of their suits and within airlocks. It's been described as sweaty feet and stale body odor mixed with nail polish remover and gasoline. Not great. Number 16. Strap yourself in. Sleeping in space isn't as easy as you think. Astronauts have to keep their bodies in sleeping bags attached to the wall and put Velcro straps around their heads to keep them on the pillow. Number 15. Close encounters. There are billions of Earth-like planets in the universe, so it's reasonable to assume that at least one is home to intelligent life. Humans are limited in our listening capacity. We may have already missed the message, but then again, maybe not. 14. Don't leave us. Every year, the moon moves 4 centimeters further away from the Earth. While this seems like only a fraction, given enough time, the moon will be distant enough to affect the rotation of our planet. Number 13. Body transformation. After just 6 months in space, severe muscular atrophy sets in as muscles waste away from disuse. Faces become red, swollen, and puffy, known as the Charlie Brown effect or puffy head bird leg syndrome. It's a real thing. Look it up. Number 12. No gravity, no sanity. Zero G also has an effect on mental health, with depression reported by most astronauts. The blood and cerebrospinal fluid can pool in the brain, causing headaches, nausea, vertigo, and even visual impairments as cranial pressure builds, pushing on the brain. Number 11. The Vomit Comet. When training for space, simulating weightlessness in a specially designed airplane is the next step up from scuba diving. Over the course of a single flight, the plane soars up in the air before performing a nosedive no less than 30 times to create brief periods of zero gravity. Number 10. Going rogue. Every so often, a planet or star is ejected from a galaxy for reasons that are unknown to science. These rogue cosmic bodies travel through space at tremendous speeds until they slam into something, causing an absolute mess of destruction. Number 9. Shine bright like a diamond. A supernova caused by the death of the star is the single largest cosmic event, second only to the Big Bang. It briefly shines brighter than all of the light in the whole universe combined and can put out over 50 million degrees Celsius. Number 8. A goddess she ain't. Venus is by far the most dangerous planet in our solar system. If the surface temperature of 500 degrees Celsius doesn't burn you to a crisp, you'll be made into a flat pancake by the immense atmospheric pressure that's 90 times that of here on Earth. Oh, and it rains acid. Awesome. Number 7. Blind as a bat. We can only see 5% of all matter in the universe. The rest is made up of dark energy and dark matter, which we can neither observe, measure, or ultimately understand. Number 6. Movie cliche. It's true, in space, no one can hear you scream. All sound consists of is a pressure wave causing atoms in matter to clunk against one another. In space, there's no air, therefore no matter to transfer the energy of the sound wave. 5. Bad odds. Despite our best efforts, training, and protocols, out of the 430 people who have been to outer space, 18 have never made it back home. That's a little over 4%, or 1 in 25 chance that should you ever ride a rocket to the stars, you could be meeting your maker. 4. Martian mask. Despite proving it's just an oddly formed bunch of rocks, NASA still had the world talking back in 1976 when the Viking 1 orbiter sent pictures back to the Earth of what appeared to be a sculpture of an alien face meant to be visible from above. Doesn't make it look any less disturbing. Number 3. Spooky star formations. There are many structures up in the night sky that bear an eerie resemblance to decorations you'd put up on Halloween. The Hand of God Nebula is so named because it appears like a giant outstretched hand. It's actually a pulsar wind nebula produced by the eventual death of a white dwarf after its supernova. Out in the Perseus cluster lies a huge fiery skull with a wide open mouth letting out an eternal silent scream. Next to the constellation Cepheus, there's a cloud of interstellar dust and gas called SH2-136 that looks like a bunch of ghosts dancing and having a party. The Skull, or Pac-Man Nebula, is actually a real name for something seen in relatively near space. For all intents and purposes, it looks like the skull of the iconic arcade game Pac-Man taking a giant bite out of the space around him. Number 2. Brains. After a supernova, the remnants of the dead star condense to form a white dwarf. Over the next 10 billion years or so, it fizzles out until it forms a black dwarf, emitting no energy, in effect a corpse or a husk of a star. This isn't the case for Tycho, which did its best zombie impression and gobbled up so much mass from nearby stars that it grew and exploded again in a subsequent supernova called a Type 1a. For those playing at home, this isn't meant to happen. And finally, number 1, the end. Just as the universe was given life in the Big Bang, so too could it all abruptly end in what is being called the Big Rip. The expansion velocity and dark force pulling on the fabric of space and time could cause it to suddenly fail. How dramatic.
Black holes may vary in size and age, but one thing is for sure, they're hungry. New black holes are being discovered all the time, and there seems to be no realistic limits to the size they can grow to. So what are some of the biggest? Welcome to Fact Nominal, and today we're traveling to the event horizon in 10 biggest black holes. The black hole is a stellar remnant, the end result of a dying star that is so dense that not even light can escape its gravitational pull. Some of these are as old as the universe, while others are being formed right this second. Not to worry though, there is little risk that the Earth will be swallowed up by one of these ravenous pits of infinite eternity, as the nearest black hole is 3,500 light years away. This closest neighbour isn't in our solar system, but it is in our own Milky Way galaxy, and it's called Sagittarius A. It's a decent size, totaling between 1 and 4 million solar masses by our best estimates. Before we delve into the biggest and baddest of the supermassive black holes, it first begs the question, what is a black hole capable of? A brief history. The concept of a black hole is a relatively new one, and we knew about them well before we were about to actually see one with our own 2 eyes in 2019. Back in 1915, Einstein's general theory of relativity described that both space and time are intertwined, and how mass bends space-time, producing gravity. A year later, Carl Schwarzschild offered a solution to Einstein's equations, noting that objects of sufficient mass would have an escape velocity exceeding the speed of light and would be unable to be observed by their very nature. His work pointed towards the existence of black holes and would later form the basis of the first model of one. Fast forward to 1939, Einstein publishes a paper seeking to prove that it was impossible for celestial objects to be so dense that their gravity prevents light from escaping. J. Robert Oppenheimer ironically used the work of Einstein and Schwarzschild to propose the first working concept of a black hole, that the continued contraction of a dying star under the influence of its own gravitational field could in fact create a body with an attraction force so intense that light cannot escape. If his name seems familiar, it's because Oppenheimer became the head of the Manhattan Project after being brought over from Germany by the Allies under Operation Paperclip. His research would lead to the development of atomic weapons. The Planck particle. It makes sense that to explore how big black holes can get, we have to understand how small they can be. Planck particles are extraordinarily small black holes and are thought to be 1.14 times 10 to the power of minus 34 meters in diameter. If that number means nothing to you, think about a decimal point followed by 33 zeros. It's actually measured in a unit called a Planck length, which is itself 1.6 times 10 to the power of minus 35, or the equivalent to something like a millionth of a billionth of a billionth of a billionth of a centimetre. This is the scale where quantum foam is believed to exist. It's the weird realm of quantum physics where laws are very different to our own world. Extremely minute wormholes open and close constantly, giving space a rapidly changing, foam-like structure. If we were ever able to harness the limitless energy of quantum foam, just 1 cubic centimetre of empty space would be enough to boil the Earth's oceans. Can they fizzle out? Before one of these Planck particles approaches the Earth, it's thought that the particle would evaporate through a process called Hawking radiation, described by its namesake, the great man himself, theoretical physicist and candidate for the smartest man to ever exist, Stephen Hawking. Though he passed away in 2018, perhaps his greatest legacy is something so simple, taking a black hole's temperature. Using a combination of Einstein's theory of relativity and quantum mechanics, he was able to explain how both come into play at the threshold of an event horizon, the point in a black hole where light cannot escape. Hawking radiation is the very slight glow, a thermal release spontaneously emitted by a black hole, relative to its mass and gravity. It is a byproduct of the conversion of quantum vacuum fluctuations into pairs of particles, one being expelled by the black hole and a matching antiparticle being driven into it. The release of this radiation reduces the mass and energy of black holes ever so slightly. Regular-sized black holes dissolve so slowly that their lifespan would likely exceed the time taken to find the nearest black hole and combine with it. A black hole with a singular solar mass will last 10 to the power of 67 years, an extremely long time. Supermassive black holes can take up to 10 to the power of 100 years to dissolve. However, micro black holes likely don't last that long, but we can't know for sure until we find one. How big are they? So to put it simply, black holes are measured using a very familiar scale, a solar mass, or the equivalent mass to our own system's sun. It's not until you understand this concept that the sheer scale of a black hole becomes apparent. It's easy to dismiss the large numbers associated with the size of a black hole until you realize that every one of those units is the mass of our sun. This is our life giver, a gigantic ball of heat and light that gave birth to life on this planet and continues to support whole ecosystems through the energy that plants absorb and turn into food. At its center, the gravity is so great that hydrogen gas is compressed on all sides so tightly that 4 hydrogen nuclei are squeezed together to form one helium atom in a process called nuclear fusion. This is the exact same process that causes the intense release of light, heat, energy, and radiation from the detonation of a thermonuclear bomb. The biggest nuke ever detonated by the United States produced a crater 2 kilometers wide and 75 meters deep. Within the sun's core, the energy produced every second is the equivalent of detonating 15 million of our biggest nukes. Eventually, the hydrogen is used up, and the nuclear fusion rate slows down enough so that the gravity causes the sun to start collapsing, resulting in a newly formed black hole. A stellar black hole is in the range of 10 to the power of 100 solar masses. Anything bigger than that is considered supermassive and can be as big as millions or even billions of solar masses. These are measured by observing the full orbit of a circling star. It has been hypothesized that it's theoretically possible that an intermediate mass black hole can exist and that weighs hundreds of thousands of solar masses. However, we are yet to see them. Any black hole that is less than 1/10 of a millimeter in size is considered a micro black hole and can be as small as one Planck particle. These are the primordial class of black hole, and as any with mass less than a single solar mass, could only have been formed during the beginning of time, the Big Bang. For a primordial hole to survive today, it would have to contain a couple of billion tons of mass inside a radius the size of a nucleus of an atom, or smaller. How are they measured? Supermassive black holes have enough mass and gravity to hold entire galaxies together and even attract other galaxies towards them, even if it's done extremely slowly over millions of years. Because they are so far away and they don't emit light, it gets a little tricky to estimate their mass. By looking at the spin and the charge of surrounding gas as it's swallowed up, scientists can determine a nearby black hole's mass. So which ones are big enough to influence the movement of whole galaxies, full of stars with orbiting planets? Number 10. NGC 4889, 2.1 times 10 to the power of 10 solar masses. A former quasar star, this black hole now has a mass of 21 billion solar masses, over 5,200 times the size of Sagittarius A, the black hole in the Milky Way galaxy. The diameter of its event horizon is anywhere from 20 to 124 billion kilometers, putting the mouth between 2 and 12 times the distance of Pluto's orbit around the Sun. It's a slumbering giant, as there is evidence new stars are forming around its margins. Number 9. APM 08279 plus 5255, 2.3 multiplied by 10 to the power of 10 solar masses. This black hole tips the scales at 23 billion solar masses and is surrounded by the largest and most distant reservoir of water ever detected in the known universe. There is so much water here that it's enough to fill the Earth's oceans more than 100 trillion times. Number 8. NGC 6166, 3 multiplied by 10 to the power of 10 solar masses. Located in the Abell cluster in the constellation of Hercules, this black hole is one of the most luminous sources of X-rays seen anywhere in the universe. Unusually, it's at the center of its galaxy and appears to exhibit a blue shift, meaning this 30 billion solar mass giant is actually moving towards Earth. Number 7. H1821 plus 643, 3 multiplied by 10 to the power of 10 solar masses. Back in 2014, this was considered the most massive of all known black holes. Also a 30 billion solar mass dead quasar. The Schwarzschild envelope diameter is greater than the margins of our own solar system. Number 6. SDSS-J1023225.31-514251.0, 3.31 multiplied by 10 to the power of 10 solar masses. This black hole is unique in the fact that it has a smaller, neighbouring black hole in its galaxy that it will eventually meet with and absorb, becoming bigger still. It only exists as the result of an estimation of an emission line equation from the quasar MG2. Despite this, we do know that it's 33.1 billion solar masses, but not much else. Number 5. SMSS-J215728.21-3602151. 3.4 multiplied by 10 to the power of 10 solar masses. This black hole is regarded as one of the most powerful quasars and the fastest growing. It's feeding its 34 billion solar mass frame at an astounding rate and growing so rapidly that the sheer volume of gas it sucks in on a daily basis causes a luminous Hawking radiation effect that shines thousands of times as bright as an entire galaxy. Number 4. S5-0014 plus 81. 4 multiplied by 10 to the power of 10 solar masses. Categorized as a blazar, this 40 billion solar mass black hole is one of the most powerful objects in the universe, putting out an energy of 10 to the power of 41 watts while being 25,000 times as luminous as the 400 billion stars in the Milky Way combined. It would give out the same energy per square meter as our Sun, even if it were almost 18 million times further away. Number 3. IC-1101. 4 minus 10 multiplied by 10 to the power of 10 solar masses. This black hole comes from the largest known galaxy in our universe. The star formation in this area is very low due to an elliptical orbit, making estimations of the black hole's size challenging and putting it into the range of 40 to 100 billion solar masses. The black hole itself is an intense emitter of radio waves. Number 2. Homburg 15A. 4 minus 4.8 multiplied by 10 to the power of 10 solar masses. With an estimated mass of between 40 and 48 billion of our own suns, this black hole surprised scientists. When they surveyed its size, it was 9 times larger than they expected, relative to the stellar mass of its surrounding galaxy, making it a big fish in a small pond. Number 1. TON-618. 6.6 multiplied by 10 to the power of 10 solar masses. The biggest of them all. It's a mouthful, technically classed as a hyperluminous, broad absorption line, radio-loud quasar. It shines with the light of 140 trillion suns and has a diameter of 780 billion kilometers, more than 40 times the size of Neptune's orbit.
In the pursuit of journeying to the stars, mankind has shot some truly crazy stuff out into the cosmos, both in the name of science and the name of, well, just 'cause we can. If any alien civilizations were to intercept these bizarre bundles, they may think twice about dropping in and paying us a visit. So what are some of the weirdest objects ever sent into space? Welcome to Factnominal, and today we're going treasure hunting in 10 of the weirdest objects ever sent into space. Number 10. Not a broken record. The spacecraft Voyager 1 and Voyager 2 were launched a mere 16 days apart in 1977 and featured the now infamous Voyager Golden Records. The mission was to photograph and document our solar system, but notable astronomer Carl Sagan raised a valid point. What if the spacecraft encountered intelligent life along the way? The Golden Records contained basic sonographic information, including greetings spoken in 55 languages. A 90-minute selection of musical excerpts from around the globe, human brainwaves, the natural sounds of Earth's animals, and even images of mathematical definitions and DNA structure. The aim was to offer a brief yet accurate cross-section of human civilization for anyone or anything to decipher should they come across it. President Jimmy Carter and UN Secretary General Kurt Waldheim also added printed messages to the package. Number 9. Music to my ears. Music has to be one of the greatest achievements of mankind, equal to or exceeding our ability to leave the confines of Earth and explore the cosmos. Walter Schirra Jr. and Thomas Stafford made history when they played the first musical instrument in the history of spaceflight. While aboard the Gemini 6A spacecraft, they decided to play a little Yuletide prank on mission control. They reported seeing an unidentified flying object with a command module and 8 smaller modules in front. It was in a north polar orbit about to re-enter the atmosphere. At the end of the transmission, the pair played a somewhat off-key rendition of Jingle Bells, Schirra on his tiny 4-hour harmonica and Stafford on percussion with a string of 5 small bells. Number 8. Stellar Send-Off. There have been those who feel a great affinity with the universe and have had the success and wealth to sponsor a trip into outer space and find their final resting place drifting amongst the stars in the great void of space. Gene Roddenberry was the original creator of Star Trek, and his last will and testament dictated that a portion of his ashes be launched along with the Space Shuttle Columbia in 1992. Similarly, James Doohan, who played Scotty in the same series, always wanted his ashes to be shot up into space. Sadly, they came crashing back to Earth after a brief orbit in 2007, and a second attempt a year later was also unsuccessful as the rocket carrying his ashes exploded over the Pacific Ocean. So much for resting in peace. Well, pieces. Number 7. Everybody loves Lego. NASA has had a long-time partnership with Lego since they introduced the space-themed Legos in 1978, a series totaling over 200 individual sets. It seems fitting then that the little plastic figurines get a chance to experience space for themselves. NASA's Juno probe took off for Jupiter in 2011, complete with some stowaways on board. There was the Roman god Jupiter holding his namesake plate, his mythological wife Juno with a magnifying glass symbolizing exploration study, and the discoverer of the huge gas giant himself, renowned astronomer Galileo Galilei. The project was appropriately named Bricks in Space and was a combined effort to inspire a new generation of children to chase careers in aerospace. After all, if Lego characters can become astronauts, then anyone can. Number 6. Use the Force, Luke. The Star Wars franchise inspired the imagination of whole generations, and it's still popular today as it's ever been, as well as its most beloved characters. It seems only fitting that a man who traveled across the galaxy at light speed, combating space monsters and liberating the oppressed, gets the ultimate tribute. Mark Hamill, who played Luke Skywalker, donated the lightsaber he wielded in Return of the Jedi as a good luck charm to commemorate the Star Wars 20th anniversary. The 7 astronauts were tasked with assembling the Harmony Node 2 module and brought the lightsaber back with them after a successful mission, safe and sound. Though they didn't bring balance to the Force, they did install a module that connected the laboratory modules of the US, Europe, and Japan on the International Space Station, as well as power and electronic data upgrades. 5. To infinity and beyond. There isn't a human being alive who hasn't seen Toy Story. It doesn't matter if you're a kid or an adult, there's something for everyone in this much-loved story about pals Buzz and Woody and their journey to find their way home. The STS-124 Discovery mission took off in 2008, with mascot Buzz Lightyear on board. In all, he stayed in space for 450 days before coming back to Earth with the rest of his crew. It was a dream come true for the plastic spaceman as he stayed aboard the International Space Station as part of Disney's Year of a Million Dreams. Number 4. Beatlemania. Sir Paul McCartney is easily the most recognizable member of the pop supergroup The Beatles. Affectionately known as Macca by the rest of the band, his voice was used as an integral part of NASA's Deep Space Network program. He recorded a simple message: "Send my love to the aliens. All the best, Paul." His voice was sent traveling in an uncountable number of directions from Earth out into the cosmos, traveling at the speed of light, 186,000 miles per second. One such target was the North Star Polaris, which is 431 light-years away from Earth. His message of goodwill to all the little green men from outer space will likely arrive at Polaris long after our great-great-great-grandchildren's great-great-great-great-grandchildren's lifetimes in 431 years. And who knows, we might even have space colonies by then, or populations living on other worlds and planets outside of our solar system. We can only dream. 3. Who ordered the large pepperoni? In an insanely expensive and arguably uber-successful publicity stunt, Pizza Hut became the first fast food restaurant in history to send a delivery order into outer space. In 2001, they agreed to a $1 million fee to have Russian space agency Roscosmos take a pizza pie into orbit to give cosmonaut Yuri Usovhoy a taste of home. It was a basic recipe, crispy crust topped with Napolitana sauce and cheese. Pepperoni was excluded in favor of salami in order to enhance the pizza's flavor in zero gravity. Extra salt and spices were used to combat the phenomenon of taste bud depletion that those in orbit exhibit in microgravity. 2. Furry friends. In the 1950s, animal rights were next to non-existent. As a result, a whole bunch of different animals were launched into space. Rights were next to non-existent. 2. Furry friends. In the 1950s, animal rights were next to non-existent. As a result, a whole bunch of different animals were launched into space in an attempt to study how living physiology is changed by the rigors of intense G-force and the weightlessness of outer space. Laika the dog was the first to be sent up by the Soviets, and in the span of just a few weeks in 1957, went from lovable street cur of Moscow to the pilot of Sputnik 2. No happy ending, sadly, as the space pooch did not survive the flight. The U.S. doubled down in 1961 when Ham the chimpanzee answered the call to arms. The space-bound simian traveled at a speed of 5,800 miles per hour at an altitude of 157 miles above the Earth. Despite the incredible forces acting on his body, he performed his tasks flawlessly and survived re-entry, earning his immediate retirement. Number 1. Forget fossil fuels. Whether you think Elon Musk is a visionary of the future or merely an over-eccentric centibillionaire, there's no denying that the man pulls some pretty hilarious publicity stunts. Back in 2018, his company SpaceX did a little bit of cross-promotion when they sent a Tesla Roadster into orbit, piloted by a brave hero and spacesuit-clad mannequin named Starman. It was a strangely appropriate way to christen and commemorate the maiden voyage of the Falcon Heavy rocket that will someday be used to ferry mankind to Mars. Both the launch and Starman's helmet cam were streamed live on the internet, and although it's impossible to hear in the void of space, the car's stereo was blasting David Bowie's hit track Life on Mars on repeat 24/7. Starman is currently cruising around in a solar orbit, will eventually cross into Mars orbit before crash landing on Venus in 10 million years' time. Today, 4,370 exoplanets have been discovered in 3,230 different star systems, and that's a lot. It seems as though, as time goes by, the number of planets we're discovering outside of our own solar system is increasing exponentially. Does this phenomenon mean that our odds of finding another planet like Earth have gone up as well? Welcome to Factnominal, and we're dishing out the details on some recent celestial breakthroughs in new Earth-like planets that have recently been discovered. The breakdown. It took a really long time to discover the first exoplanet. Scientists knew that they have to be out there. It just wasn't until 1995 that we had confirmation that our solar system wasn't a fluke or a cosmic one-off. There were other planets out there. Then we have the ambiguously named super-Earths, or planets with mass 1 to 10 times that of our planet. 1,329 exoplanets have been confirmed as super-Earths so far, or a little under a third. This name is misleading, however, as they can be made up of rock, gas, or a combination of both. They can range from hot Jupiters orbiting so close to their stars that they're essentially fiery orbs of doom, to being so far away from their sun that they're cold, inert balls of rock devoid of any atmosphere, and everything in between. That brings us to the Earth-like planets, between 0.5 and 1.5 times the size of our blue world, and this time, the name isn't just misleading clickbait. The age-old question of whether Earth is unique in the universe and whether others could support organic life has been answered. Around every star exists a habitable zone. Rocky super-Earths in this range are called Goldilocks planets, where the temperature is not too cold as to form ice, not too hot to form steam, but just right for the existence of liquid water. Based on what we know, carbon-based life needs water to survive, so it's these planets that have the best chance of finding ETs and little green men from outer space. Added bonus, the ability to support life makes them ideal candidates to set up human colonies. We just need to figure out a way to travel the mind-bogglingly huge distance first. As you would expect, these planets are exceedingly rare. Only 24 Earth-like planets have been detected so far. This begs the question, which of these are best suited to support life? Number 5. Kepler 1649c. While looking through old observations from the Kepler Space Telescope retired in 2018, astronomers stumbled across a hidden gem in April of this year. It turns out a computer algorithm misidentified an exoplanet, and not just any exoplanet, one with a rocky composition that sits in the Goldilocks zone. If the data sent back by the Kepler Space Telescope was not analyzed manually, then we may have missed one of our best chances at finding life outside of our solar system. It's very similar in size to the Earth, but little is known about its atmospheric composition, whether it does contain water, and the topographical landscape. It only receives 75% of the light that we do, but it's enough to support life. It's relatively close to its red dwarf, with a year lasting a brief 19.5 Earth days. The big worry is whether the constant bombardment of the surface of Kepler 1649c with ionizing radiation has either prevented the formation of life or periodically kills it off, only to start again. Red dwarfs are notoriously unstable, and such close proximity lends itself to an unstable environment on the exoplanet. Despite it having an Earth Similarity Index, or ESI, of 0.90, the human race will almost never certainly get close to it, due to it being 300 light-years away. Number 4. TRAPPIST-1d. The TRAPPIST-1 system is a literal treasure trove of Earth-like planets. All are rocky, and some may hold more liquid water than the Earth. At first, it was thought to contain 3, and then later 2, and finally, on some closer inspection, an amazing 7, all with the potential to contain water in either solid, liquid, or gaseous states. TRAPPIST-1d is the one that astronomers are really excited about, sitting right on the edge of the habitable zone. It's much smaller than Earth, only 77% the size and having 41% the mass. It has a molten core and an atmosphere much like Earth's. Bizarrely, it orbits a rare ultra-cool dwarf star, less than a tenth of the size of the Sun. But it's the little engine that could, having the ability to live up to 5 trillion years, or 500 times longer than our Sun. TRAPPIST-1d still receives just 4.3% more sunlight than the Earth, courtesy of it sitting so close to it. Up to 5% of its mass could be liquid water. In comparison, that is 250 times the water found in all of Earth's oceans combined. This vast sea may have a frozen, icy crust, but it's not certain whether any dry land would be present on the exoplanet. Number 3. K2-72e. The Kepler Space Telescope picked up a peculiar exoplanet during its second light mission. It's remarkably similar to Earth. However, scientists are having trouble gathering information to fill in the gaps in its planetary story. So far, we know it's a rocky exoplanet, around 2.2 times the size of the Earth. It sits just 1/10 the distance from its star compared to our Earth's distance from the Sun, putting it in an orbit much the same as Mercury. Unbelievably, 4 other exoplanets sit in closer orbits to the K2-72 star. It's unusual in the fact that it's tidally locked to the Sun, meaning that one full rotation of the planet is equal to the duration of its solar year. This means that one side of the planet is bathed in constant sunshine and the back half is in perpetual darkness. It receives 11% more solar radiation and sunlight than the Earth, meaning the sun-facing side may be hot enough to evaporate water into steam. However, this isn't been confirmed yet. Most Earth-like planets don't have the conditions to boil off oceans. However, K2-72e is unique in that it may have a very broad temperature range between the frozen wasteland of the dark side and the scorching tip of the planet closest to the star. If there is dry land in this zone, then it's entirely possible that life exists in this temperature range, even if it's daytime the whole year round. Number 2. TOI-700d. TOI-700d is the fruits of the labor of NASA's Transitioning Exoplanet Survey Satellite, called TESS for short. This program was developed in direct response to the first super-Earth ever discovered to find out if Goldilocks exoplanets really do exist. NASA's Spitzer Space Telescope was used to help model the exoplanet's potential environments and assess its viability as an Earth-like planet. The star at the center of this system is a cool M-class, roughly 40% of the Sun's mass and around half the surface temperature. TOI-700d is the outermost of 4 planets in the system and is a little chunky, 2.6 the mass of Earth. Despite its size, it does still sit well within the habitable zone of its star and does have a rocky composition. The data points to the exoplanet being almost completely covered by ocean and having a carbon dioxide-heavy atmosphere with dense layers of cloud on its sun-facing side, similar to how scientists picture a young Mars. It's tidally locked, meaning that the planet may contain a huge ice cap covering the whole backside of the planet, with the front half a mixture of oceans and rocky pinnacles of dry land. Number 1. Teegarden Star B. The pick of the bunch, Teegarden Star B is almost exactly the same size and mass as Earth, with a 60% chance of having a temperate surface environment. It's very likely that the surface of the planet ranges from 0 to 50 degrees Celsius, with the majority of the planet enjoying a balmy 28 degrees. This exoplanet is affectionately referred to as Earth 2.0, and for very good reason. It's much closer to its star, completing a solar year in just 4.9 Earth days. The closer distance doesn't matter, as the red dwarf at the center of its system is much smaller and cooler than our Sun. The good news is, unlike other red dwarfs, this star is relatively stable and not prone to periodic emissions of damaging radiation from powerful solar flares. This little beauty has been awarded with the highest ESI score ever, coming in at 0.95. At 12 light-years away, it's currently the fourth closest Earth-like planet and the best candidate for further study. Scientists want to know more about its atmospheric composition and whether the gases present closely resemble the nitrogen-rich, oxygen-containing air of Earth. Current analysis points to the possibility that the surface is home to an ocean of water. Sadly, with our current aerospace technology, it would take an astounding 208,430 years to travel to T-Garden Star B, and that's only a one-way trip.
Mars is where the future is. Mars is the closest planet to the Earth that has on it all the resources needed to support life and therefore technological civilization.
The Red Planet, our mysterious celestial neighbor and ambitious destination of SpaceX and the international space community. Every day, we learn more and more about Mars as the race to unlock its secrets ramps up.
Mars, it just looked like a cold, dry, dead planet. But the more we study it, the more we learn that it's actually dynamic, alive.
But for every answer we discover, a million more questions arise. So what do we know? Welcome to Factnominal. Today, we're uncovering the latest scientific breakthroughs on the infamous Red Planet in Mars Space Discoveries 2020. Number 10. Build an Ark. Data collected by the Little Engine That Could, NASA's Curiosity rover, has discovered evidence that a flood of biblical proportions happened near the equator of Mars around 4 billion years ago. It's likely that the heat from a huge meteoric impact was so great that it melted ice stored on the Martian surface. Sediment samples show geological features called megaripples, indicating that the landscape was drastically changed by wind and water. These take the form of anti-dunes that are 30 feet high and repeated every 450 feet or so. This phenomenon is incredibly similar to features formed on Earth by melting ice 2 million years ago. The meteor would have also released carbon dioxide and methane trapped within the ice, forming a warm, wet atmosphere for a short period. Rain clouds would have dumped precipitation across the planet, creating the gigantic flash flood in the Gale crater. Number 9. Hidden Gem. Here on Earth, mineral zircon containing trace amounts of uranium is fairly common in the continental crust of the surface. It provides important information about the age and origin of large geological features like canyons, mountain ranges, and extinct volcanoes. Mars' crust is fairly unevolved and better resembles the surface of Earth's seafloor, which is relatively rare in zircon. Close analysis of an ancient meteorite originating from the Martian surface has been found to be surprisingly high in zircon. Furthermore, the uranium isotopes used to determine the age of the meteorite show that while most were formed at the planet's birth 4.5 billion years ago, others are much younger, only 300 million years old. The newly formed zircon brought to the surface by volcanic activity on Mars gives scientists a rare insight into the composition of the planet's core and its structure. Number 8. Martian Lakes. 2 years ago, scientists confirmed the existence of a large saltwater lake under the ice cap located on the south pole of Mars. Now, they've found 3 more subsurface lakes with a surface area of 29,000 square miles, or 1/5 the size of Germany. The largest of the bunch measures 18 miles across. The lack of a dense atmosphere makes liquid water impossible on the Martian surface. The pressure just isn't great enough to change state from a vapor. The presence of underwater reservoirs points to the fact that at one time, billions of years ago, Mars had seas and lakes all across the planet. The salty subterranean lakes are potential habitats for life, as even here on Earth, subglacial lakes in Antarctica are still able to support quite complex organisms. The only problem is the water may be too salty to sustain life. Number 7. Interplanetary seas. There are 2 theories of how water arrives on a planet. One is that it's deposited when asteroids containing frozen water crash into the surface. The other is that water is formed from oxygen and hydrogen during the birth of a planet. Results from the analysis of the Black Beauty Martian meteorite shows that high levels of oxygen were released during impact, with the only explanation being that water was already present. What this means is that potentially every rocky planet could have hidden stores of water by very definition. Hypothetically, the possibility of life existing on a planet other than our own has just skyrocketed. It's clear now that there was water on Mars for the first 90 million years of its lifetime, a long time before the water-rich asteroids pelted inter-solar system planets. Life could have had tens of millions of years to develop on other planets as well. Number 6. And poof, it's gone. So if Mars once had a great expanse of seas and oceans, then where did it all go? Scientists have found that the upper atmosphere of Mars contains a large percentage of water, courtesy of the MAVEN orbiter, which dips into the planet's atmosphere to take samples every 4.5 hours. At the time water was present on Mars, the atmosphere was much thicker, indicating that much of this atmosphere has now been lost into space. In summer, Mars is closer to the Sun. Water stored in ice evaporates into the air, where dust storms funnel it into the upper atmosphere and eventually outwards from the planet. Solar radiation then breaks down the water molecule into its base parts, oxygen and hydrogen. This didn't happen on Earth thanks to the hydropause, a layer in the atmosphere that's cold enough to condense water vapor into droplets, storing it in clouds. Number 5. The other rover. The European Space Agency is developing their own rover, and it may be saying hello to the Curiosity and Perseverance sooner rather than later. The ExoMars Rosalind Franklin will land on Mars a little differently than its cousins, relying on deploying 2 massive parachutes to rapidly slow its rate of descent. The ExoMars rover will continue the search for life on the Red Planet and is due to be launched in 2022, before arriving at the Oxyplanium region of Mars. Number 4. RoboPoop. NASA's Perseverance rover is set to land in Mars's Jezero crater mid-February 2021. One of its many tasks is periodically taking core samples before laying them in its wake in protective containers. The idea is that the manned mission to Mars recover these samples before analyzing them in orbit and maintaining a quarantine zone. The sediment samples are vital for assessing the likelihood that a human settlement could be established on Mars. If the lack of sunlight could be overcome, the next question is, can we grow food in the soil? And if so, can we grow enough to sustain a population large enough to not only inhabit the planet, but also colonize it and raise second and third generations of children? There may even be signs of life in the samples, in the form of microscopic fossils and organic molecules essential for metabolism. Number 3. Fingers crossed. On board NASA's Perseverance rover is a peculiar device called the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE for short. The aim is to convert the Martian air into oxygen, though there's no certainty that the machine will work. Oxygen is essential for respiration and for complex life to thrive. If we're ever to colonize Mars, then there needs to be ways to effectively generate enough oxygen to form an atmosphere inside the colony to support the number of humans inside. Mars' atmosphere is 95% carbon dioxide and only 1% thick as it is here on Earth. The MOXIE uses an electrochemical process to separate 2 oxygen atoms from each CO2 molecule. If enough oxygen can be extracted, it may eventually be used to power rockets launched from Mars to Earth. A crew of 4 would need around 55,000 pounds of thrust generated from 15,000 pounds of oxygen rocket fuel. Number 2. No more bumpy landings. Terrain relative navigation will be trialed on the NASA Perseverance rover for the first time in an attempt to land the buggy closer to its destination, preventing months and potentially years of wasted travel time on the surface. The previous mission to land the Curiosity rover needed a car park-sized space clear of debris, land formations, and difficult terrain in order to successfully deploy. Now, a combination of stored topographical maps with the aid of real-time visual analysis allows the lander to identify craters, cliffs, and rocky debris and adjust the landing zone accordingly. The system provides a safer landing alternative while avoiding hazards. If successful, it would be a feature on the spaceship that takes mankind to Mars. Number 1. new tricks. The Perseverance will also have a few tricks up its sleeve to do things the older Curiosity rover only dreamt of. The Mars Environmental Dynamics Analyzer, or MEDA, is a combination sensor array on the rover that will record weather conditions on the surface more accurately than ever before. Wind, dust, temperature, pressure, and radiation levels will be tracked in order to form patterns and how they change over the seasons on Mars. Little known fact, the temperature on Mars can fluctuate by 90 degrees Celsius over the course of just one day. The rover will also pack a RIMFAX, essentially a top-of-the-line ground-penetrating radar. It can scan deep underground and differentiates between dust, sediment, rock, boulder, and ice layers. The geological structure of the Jezero crater may uncover Mars' watery past. The data collected helps prepare the equipment needed to land humans on Mars, as well as give a valuable insight into how the planet turned from warm and habitable into a lifeless dust ball. The night sky is dotted with countless stars that look so peaceful. But lurking in the deep, dark recesses of the universe lie silent, deadly, ticking time bombs. Cosmic assassins with so much raw potential power, when they strike, it could mean the end of planet Earth. Welcome to Factnominal, and we're going to give you another 10 reasons to be nervous in 10 terrifying space disasters waiting to happen. Number 10. Asteroids. While asteroids are formed close to stars and are generally made up of a combination of metals and rocky materials, they can group together in belts, but also alarmingly can break away as rogues and be shot out into space all by their lonesome. Almost 5,000 asteroids are close enough to the Earth to pose a threat, with 2,000 making it onto the watch list of the Near-Earth Objects Observation Program. These troublesome balls of rock have hit home millions of years in the past, namely during the Cretaceous extinction event where 1/5 of all animal species were lost, as well as the End Permian extinction event widely regarded as the greatest single disaster in our Earth's lifetime. Frighteningly, we have had similar rocks hurtled down to Earth in modern history, as is the case with the Tunguska event and the Chelyabinsk meteor. Number 9. 1950 DA near-Earth asteroid, coming in at over 1.3 kilometers in diameter and with a mass of 40 billion tons, 1950 DA is a doozy. If it impacted the Earth, the explosive force will exceed the total of all the nuclear weapons in every arsenal around the world combined, and then some. Its orbit is bringing the asteroid close to Earth, and will at some point in the future be so close it has astronomers biting their fingernails down to the quicks. In 2032, it will approach within 11.3 million kilometers, which may sound like a long distance, but it's not. Think of it as being 1/6 the distance to Mars. If we live long enough and the Earth survives human habitation, there's a 1 in 8,300 chance it will directly collide with us in the year 2880. If the asteroid impacts into the Pacific Ocean, it will create a shockwave that will whip the seas into 120-meter-high waves, slamming a wall of water higher than a 30-story building into our coast. Number 8. Apophis asteroid. Back in 2004, a 450-meter diameter asteroid was discovered, and Apophis was given a danger level score of 4 out of 10 on the Torino scale. It has a 1% probability of colliding with the Earth in 2029 when it comes within a hair of the Earth, just 31,000 kilometers away. It'll be close enough for people to observe it with the naked eye, without the use of telescopes. 7. 2010 RF-12. There is a 5% or 1 in 20 chance that 2010 RF-12 will collide with us in the year 2095. It's a baby as far as asteroids go, tipping the scales at a mere 500 tons. But this tiny rock will produce 9 kilotons of explosive energy on impact, the equivalent energy of around 60% of the nuclear bomb dropped on Hiroshima. While it's not world-ending, it's still extremely significant and able to wipe out millions of people off the face of the planet if it makes landfall in a densely populated area. Number 6. Falling comet. Comets contain ice and dust, and as a result of their formation in the deep void of space, characterized by their long tail they get as they pass by a heat source and the ice melts to liquid water. The biggest difference to asteroids, however, is in the orbit patterns. Asteroids group together in belts, orbiting close to a star or planet. Comets are completely different in the fact that their orbits are extremely long and wide, sometimes completing a journey 50,000 times the distance from the Earth to the Sun. Number 5. Swift-Tuttle. The Swift-Tuttle comet is massive and has a real chance of smashing into the Earth. It's still a long way off and won't be a problem until the year 4479. But scarily, this is the same time that has passed between the modern day and 500 BC, the time of the philosopher Confucius, the birth of the Buddhist religion, the rise of the Iron Age, Celts, and the height of the ancient Greek Empire. So it's not actually that far away in terms of the lifespan of civilized Homo sapien man. It would slam into the Earth with 300 times the force of the meteor that wiped out the dinosaurs from the face of the planet, meaning that no organism would survive. Well, maybe with the exception of a few species of extremophile bacteria or hardy microbial life such as tardigrades or water bears, nature's true cockroach. It's not only this huge impact which would do damage, it's the trailing tail of meteorites, dust, and other matter that would normally burn up in our atmosphere, but at this close range would pepper the Earth with a shower of Armageddon-like proportions. The end result would be an uninhabitable frozen rock where our blue-green Earth used to be. Number 4. Solar flare. From the perspective of the surface of the Earth, the Sun appears to have a fairly uniform shape and size, putting out a constant rate of heat and light that plants need to grow and support the massive terrestrial and aquatic ecosystems on Earth that we ourselves are part of. The truth cannot be anything more different. The surface of the Sun is an ever-changing mixture of cold spots and solar flares that spew forth large quantities of ultraviolet radiation, X-rays, ionizing radiation, and electromagnetic energy. If that sounds scary, that's because it is. When this eruption of energy meets the delicate atmosphere of the Earth, it creates geomagnetic storms, which can be quite pretty in the case of the southern and northern lights phenomena. But the huge electromagnetic disruption would wipe out every device and electrical circuit across the globe, and the sky would light up as an eerie green as far afield as the equator. Not to mention the huge amount of radiation our bodies would absorb and the inevitable damage to our DNA structure. Welcome to the Dark Ages. 3. Star explosion or supernova. At the end of their lives, stars run out of the fuel necessary to sustain the nuclear fusion reactions in their cores. They eventually swell outwards, engulfing planets and nearby celestial bodies until they eventually undergo supernova. This cosmic event releases energy, radiation, and heat in an explosion so gigantic that its luminosity briefly outshines the rest of the entire universe. Number 2. Cosmic rays. Following a supernova, the expansion of a ring of harmful gamma radiation spreads out across the cosmos in a disruptive wave. If a close enough star to Earth dies, the resultant band of electromagnetic radiation could literally shift our magnetic axis, strip away our atmosphere, and leave our planet an inert ball of rock totally incapable of supporting life as we know it. Picture the desolation of the Moon, only bigger. Number 1. Betelgeuse. 650 light-years away sits the star Betelgeuse. And no, we're not talking about that hit movie from the 80s about a poor deceased married couple tormented by a malicious spirit with a white face and green hair. Betelgeuse the star is currently in its final stage, a hypermassive red giant that's on the tipping point of going supernova. Granted, the radiation from such an explosion would take millions of years to reach our planet, but it would almost certainly spell our doom. So there you have it. We hope you don't have too many nightmares tonight thinking about the myriad of cosmic nasties out there. It's probably best not to think about it after all. Ignorance is bliss. If you love our content, please let us know in the comments section below. Why not give us a like and subscribe while you're at it, so you don't miss out on any of our other amazing content.
Not everything in science can be explained. It's safe to say that we have learnt only a fraction of the secrets as to how the universe actually works. Everything we know so far has been learned from objects rarely falling to Earth, and telescopes that can detect electromagnetic radiation outside the visual spectrum. When you think about it, we haven't traveled very far from our blue planet, and there are many scientific observations we've made that defy explanation. So, what are some space facts that have left astronomers stumped and scratching their heads? 15. Scouting ahead. In 2017, the Nejlll Observatory spotted a bizarre object they dubbed Oumuamua, Hawaiian for scout. It's 167 meters wide and a kilometer long, giving it the appearance of a cosmic cucumber. It's traveling way too fast, indicating some degree of self-propulsion. A professor from Harvard University has suggested it may be an alien space probe or scout craft with a solar sail. After being in our solar system for over 250 years, Oumuamua has passed out of observable range, so we may never know for sure. 14. Hip to be square. Gas clouds form amazing shapes throughout the galaxy, but there are no straight lines in nature. The Red Rectangle Nebula is oddly geometric in shape, and astronomers have no idea why. It's located in the constellation of the Unicorn, Monoceros, around 2,300 light-years away. It's a binary system with two stars sitting at its center. In a rare phenomenon known as extended red emission, the surrounding dust glows a fiery red color. It's not known why the shape is so symmetrical or how it was formed. 13. On Cloud 9. Astronomers are convinced there is a mysterious planet out beyond Neptune that also orbits the Sun, the unimaginably named Planet 9. It's not without precedent. When the asteroid Ceres was first discovered, it was misclassified as a planet. Pluto was also regarded as a planet until quite recently. Though we are yet to glimpse it, calculations say it's likely 10 times the size of Earth, 200 times further out from the Sun, and its solar year is the equivalent of 10,000 Earth years. That's far out. 12. The unseen. Dark matter is a hot topic, discussed by big-brain scientists all around the world. Galaxy X was discovered when some unseen force caused ripples in the disk of the Milky Way galaxy in 2015. It's a dark, dwarf galaxy that alters the motion of our system with its gravitational pull. It's thought to be made of up to 99.99% dark matter, with over 1,000 times the normal amount. Only 4 dim stars shine out from its otherwise dark complexion, and is likely the first of its kind to be discovered. 11. What is it? El Pizarro was first discovered in 1979, and there has been much debate since on what it actually is. Some say comet, others say asteroid. Thought it had the characteristics of both. It sits in the orbit of an asteroid belt, but has a tail, despite being too far from the Sun to melt ice. One possibility is that it's a slowly dispersing debris field from a collision. The Castellea spacecraft was meant to be launched in 2028 to finally solve mystery. However, funding cuts have grounded the mission. 10. Smoke signals. Tabby Star is a highly irregular resident of the constellation of Cygnus. Its brightness can suddenly drop by a huge 22%, a factor seen nowhere else in the known universe. It's given rise to the theory that this may be communication from some extraterrestrial civilization, or alien structures harvesting energy from their nearby star. Generally, when a planet obscures a star, it experiences a 1% drop in light, causing the twinkling effect in the night sky. But scientists have no explanation for a variance this large. 9. Long-distance call. Fast radio bursts, or FRBs, are sudden, rapid chirps of radio waves lasting a few milliseconds and were only first picked up in 2007. After more than a decade, there is still no working theory on what causes them. They originate outside of the Milky Way, and to be seen at this distance, they have to release as much energy as the Sun does in 80 years, in a fraction of a second. Some FRBs actually repeat, forming what may be described as a sign of intelligent communication. 8. Donuts. Galaxies come in 2 shapes: a flat spiral like the Milky Way, or an elliptical shaped like a football. Hoag's object has neither. It has an old yellow nucleus surrounded by a ring of younger, hot blue stars. Between the core and the ring is nothing, with the galaxy resembling the structure of an atom. It's thought to be the result of 2 galaxies colliding. However, after 70 years advancement of theoretical physics, it's unlikely to be the cause creating the abnormally shaped galaxy. 7. Bermuda Triangle of Space. The South Atlantic Anomaly, or SAA, is a section of the Earth's magnetic field known as the Bermuda Triangle of Space. This magnetic field isn't aligned perfectly to the rotational axis of the Earth, so causes the Van Allen radiation belts to dip close to the Earth around 200 kilometers above the South Atlantic Ocean. When nearing this area, astronauts have reported being woken up by a sudden, unexplained lights that are so bright they light up the space station like daylight. Computer malfunction and cease to work, and the Hubble telescope is unable to take any clear images. 6. Star inception. The idea of a star within a star was thought to be theoretically possible, but non-existent until the discovery, in 2014, called a Thorne-Zitkow object. A red giant combines with a neutron star, cannibalized after a hit-and-run event. This phenomenon causes it to swell to around the size of Saturn's orbit around the Sun. Scientists are unsure what happens when the envelope of a neutron star meets the red giant, but surface temperatures soar to 1 billion degrees Celsius, hotter than any other star. 5. Zombie diamonds. PSR J17191438 is a pulsar. More accurately, it's a star that was born from a supernova of a dying star. These zombie pulsars emit 2 cones of light and rotate around a spin axis. They contain the mass of the Sun in an area the size of a large city. This one has an orbiting planet that is made of extremely dense carbon. In other words, diamonds. Astronomers think that this planet could actually be the core of a dead neutron star. But it's just a guess, as to no one can explain what's going there. 4. Nuclear football. Vega is a young star that is burning much hotter than it should be for its age. The young achiever is shining so bright that the forces exerted on its matter are squeezing it into a weird oval shape like a football. It's unclear why the star is rotating so quickly around itself. But if it continued, the star may be ripped apart, something never before seen, and an event that doesn't fit the current astrophysical model. 3. Older than Father Time. It's generally agreed by the scientific society that the universe is roughly 13.8 billion years old. We won't bore you with the maths, just trust us on this one. Methuselah's star was named after the over 969-year-old grandfather of Noah the Ark builder from the Bible. Like its namesake, the star is also ancient. But according to its composition, brightness, and distance, the stars could be as old as 14.4 billion years, seemingly predating the Big Bang, which is impossible. 2. I am speed. Most stars travel in a fixed, stable orbit. However, HEE 0437543 is the black sheep of the family. It hurtles through space at terrific speed at 1.6 million miles per hour. The star is young, only around 30 million years old, and is thought to have formed near the center of the Milky Way galaxy. It is unknown what caused the galactic slingshot. However, one theory is that the star narrowly escaped a close encounter with a supermassive black hole at the center of Sagittarius A, launching it out to space. 1. The infinite universe theory. One of the most mind-bending theories is that the universe we live in might not have an endpoint, but instead goes on forever. Scientists theorize it's possible that if you flew to the end of the universe, you never reach it. Just an infinite continuation of stars, planets, and black holes. Not everyone agrees with this idea. The multiverse theory postulates that you would eventually reach the end of our universe and then transition into another universe, and then another, and another, and another, for an infinite amount of time. If either of these theories is true, Earth as we know it probably repeats itself over and over.
The universe is an unfathomably large place. In fact, it's so big, we don't actually know what happens past what we can detect. It could spread out infinitely, or be infinitely spreading. It's anyone's guess. Given this scale, there must be other planets out there similar to our own. So what is a super-Earth? And has one been discovered that could support life? Welcome to Fact Nominal, and today we're looking for a new planet Earth, only upsized in the discovery of the super-Earth. What is a super-Earth? A super-Earth is classed as any planet outside of our solar system that has a mass of between 1 and 10 Earths. It took a long time to discover the first exoplanet, and as you could imagine, it was a pretty big deal back in 1995 when we confirmed our solar system wasn't an anomaly in the universe. Fast forward to the present day, and there are 4,292 confirmed exoplanets, a number that is growing exponentially with more and more being discovered each year. Of these exoplanets, roughly 10% have been confirmed as being super-Earth size, and that's not even the craziest part. There are an estimated 155 billion super-Earths in our Milky Way galaxy alone, making it the most abundant type of exoplanet. In order to understand the formation of life on our planet and the possibility that it could evolve on other worlds, we have to look outside our solar system. But if there are so many super-Earths, what makes these ones so impressive? It's all about scale. Cosmic bodies are so far away, the distance and numbers become so large they start to lose all meaning once we start talking about 10 to the nth power. To get an idea of just how large the universe is, it helps to put it into a scale we can understand. Imagine the Earth as a single grain of sand, with the Moon a speck of dust orbiting from 1.5 centimeters away. Comparatively, the Sun would be around the same size as a pool ball 6 meters away from the Earth. Keep in mind the largest known star, Canis Majoris, would be 39 meters in diameter, 684 times the size of our own Sun. The solar system is 4 football fields wide, with our little pool ball Sun at its center. The star nearest to us, Proxima Centauri, is now 1,572 kilometers away. Take another step back. The Milky Way galaxy is 46,375,000 kilometers wide compared to the tiny grain of sand that is the Earth. Now, imagine that our solar system is the grain of sand. It sits in the Milky Way galaxy, which is 50 kilometers wide, and our nearest neighbor, the Andromeda galaxy, is 1,012 kilometers away. The observable universe sits in a field of view that is 37.2 million kilometers in diameter. Finally, shrink the Milky Way galaxy down to that grain of sand. The entire universe is as big as the Empire State Building. Light leaving our galaxy travels 1 centimeter away to the Andromeda galaxy, taking 2.5 million years to complete its journey. The universe is almost too big to comprehend, which begs the question, how many Earth-like planets really exist? The Drake equation. Dr. Frank Drake put forward a simple equation in 1961 to not only quantify the potential number of civilizations in the universe, but also to stimulate scientific minds to start prioritizing the answer to the big question, are we alone in the universe? The equation is formed by simple variables that add up to give you the number of civilizations in the Milky Way galaxy who are advanced enough to produce detectable electromagnetic signals. It's the average rate of star formation in our galaxy times the fraction of those stars that have planets times the average number of planets that can potentially support life per star that has planets, times the fraction of planets able to support life and actually do at some point, times the fraction of planets with life that go on to develop intelligent life, times the fraction of civilizations that develop the technology required to transmit detectable signs of their existence into space, times the length of time the civilizations exist and release their signals into space. There's no real way to determine any specific numbers for any of the terms in the Drake equation. However, the concept was so profound that it prompted the formation of the Search for Extraterrestrial Life Institute, or SETI. SETI are the ones keeping an ear out should anyone be making a long-range phone call from way outside our solar system. Goldilocks planet. The habitable zone describes the range of distance a planet can be from its orbited star while still being able to maintain liquid water. We only know of carbon-based life, and it's clear that other carbon-based life would need water to form and survive. These planets are also known as Goldilocks planets.